Hello, my name is Jose Sainz. I work at the Fraunhofer IFF in Magdeburg, Germany. I work in the Department of Robotic Systems, and I'm the group leader for assistive, service, and industrial robots. I've been working in robotics for over 20 years now, and some of the things that I've done in the past are looking at human-robot interaction, collaboration, safety, and standardization. Today, I'm going to talk to you on behalf of the Regulate project about the topics of product safety, standardization, and post-sales duties. What's important for me to talk about in this situation is we're looking at robotics applications, and the question from Regulate is, what does AI and how does the use of AI in new ways change the way that I'm considering these topics of product safety, standardization, and post-sales duties? Okay. So with that being said, let's jump right in. Today we have 3 modules for you. The first module is product safety. Then we're going to talk about standardization, and we're going to wrap this up with the idea of post-sales duties. What's important for me to also convey to you is to look at this from 2 different perspectives. So we have a lot of stakeholders who we believe will be interested in this material. And in this situation, we are dividing it up between manufacturers of products, people who are bringing these products onto the market, who are developers, who are aggregating components and putting them together, and then selling those to consumers or to other customers in the business world. And on the other side, we're looking at this from the user perspective. So as somebody who buys these types of products, what do I also need to consider? And it's interesting because there are requirements and some specific challenges from both sides of this equation. Okay. So as an overview, again, to continue, when we talk about product safety, the things that we want to cover are, how is product safety achieved? What is a so-called conformity declaration, and what does this mean for me as either a manufacturer or as a user of products? What do I need to consider specifically when there's AI involved? And then we're going to talk about a risk assessment, what that is, how you can do it, and where you can find some resources for supporting your risk assessment processes. And again, what you need to know as both the manufacturer and as the user. Okay, looking at standardization, what's really interesting is the question of course, what is the standard? Why is it important? And what is this idea of a so-called harmonized standard, and how do they differ from each other? What's the difference between a standard and a law? And finally, how can standards help me to understand the different risks and the different things that I need to consider when I have AI in my products, and specifically in my robotics applications? Okay, and the final module, module 3, is the idea of post-sales duties. So what is this, and what do I need to consider, again, as a manufacturer and as a user of these products? Okay, so jumping into module 1, talking about product safety. What's important when we're considering this from the European context is we have the Machinery Directive. And the Machinery Directive tells you all of the requirements we have to do in order to make a product, a machine, safe that we're bringing onto the market. It's interesting to note that the currently available Machinery Directive will be replaced by the Machinery Regulation. This was just accepted by the European Commission this year. And there's a phase-over period, so this won't be completely active until January of 2027. So within this time, we have the old Machinery Directive is still valid, but of course, we're looking towards the new Machinery Regulation. And in this section, I'll talk a little bit about what some of these changes are and what we need to consider. So starting again at the very beginning, what is machinery? What do we mean when we say this word? And in this case, we mean that it's an assembly with at least one drive system. So there's something happening that is driven. It's electrical, pressure-powered, steam-driven, not something that's moved by a human or by an animal, right? So those aren't machines. And these machines are typically made for a specific application. And What we also have in this context is what's known as a partly completed machine. So in this case, we often talk about robots as a partly completed machine because you can buy an articulated 6-axis robot arm or even with less axes, and that does a certain job, but not until you put it in an entire application with different safeguards, with different safeguarding sensors, is it then a complete machine. So the robot is typically known as a partially completed machine. And these are two important topics that often come up when we're talking about robotics, so that's why we brought that in here. Okay. Now when we talk about product safety, we again have the user perspective and the manufacturing perspective. So the manufacturer wants to make sure that their products are safe. So what they have to do is they have to consider different product safety laws, guidelines, and also standards. And they go through this process called a conformity assessment. And as a part of that, they do a risk analysis and they write an operating manual. And in this manual, they are telling the user how they should use it, what they should watch out for, and what some of the possible hazards are. If you're looking at it from the user side, of course, you need to consider your work or safety laws. You need to make sure that anything that you're buying has the CE mark already affixed to it. So that's really important. If you buy something that doesn't have the CE mark and you use it, that's your problem, that's your liability. And that's something that not everybody knows. So even though the manufacturer has already done their risk analysis, as the user, you're also going to do your own risk assessment because the manufacturer, of course, doesn't know all the details of your application and what's happening in your factory where you're using it. And that's for you as the user, as the manager, to make sure that you're doing this. And as a part of that, what you also do is provide instructions and training materials that go in addition to the operating manual from the manufacturer to your employees. And the idea is that you're making this equipment as safe as possible for your employees. Okay, really important to understand the distinctions there. When we talk about what are the typical sources of product safety issues, most people consider the top two, which are construction or development efforts, meaning that you made some kind of a wrong assumption, you made a bad calculation, you didn't put in some kind of a safeguard in order to cut costs or things like that. And what you can also often consider is a manufacturing defect, like you have some kind of material default, things that are typically covered in a warranty or in a guarantee. But in addition to that, what often happens as well is we have faulty instructions. So what you have in the user manual is incomplete, warnings are missing, and what's also an issue is exaggerated advertising promises. And as a final source of error, there's the idea of product monitoring errors. So again, as a manufacturer, it's important for you to actively see how your product is being used on the market. And if something happens, if users are getting injured because of it, you need to either act by yourself or you can wait until somebody within the EU will also contact you and tell you you need to take specific actions to remedy any kinds of things. And the idea here is this is what we all know as like a product recall. And that happens, I think, more often than we really know. Okay, so when we talk about the conformity assessment, what we've said now is we have the machinery directive is a very important piece of legislation, and this tells you, for example, all the different things that you need to consider to make sure that your product is safe. So what you do is you have to go through the CE process, and the CE process is a so-called conformity declaration. And there are different ways to do this and different ways of testing and validating that the machinery is correct. So what we're looking at right now is the different level of procedures for assessing the conformity of machinery based upon the older machinery directive. And as we see here, we have different types of machines, and these different types of machines have different types of hazards associated with them. So there's an annex, and if the machine is in this annex, then it means that either you're able to do the testing and validation yourself, which is the top row, or that you need to go through a so-called notified body, or you need to do some other kinds of checks and have somebody else double check your tests and your measurements so that we know that this product is safe to go onto the market. So right now, according to the Annex 6, robots are things that you can do in a self-conformity process. So you do not need to go to a notified body. You do not need to pay somebody like TÜV in order to ensure that your robotics application is safe. Of course, you're still allowed to, and you can do that, and if you don't want to take on that responsibility, that's something that is possible for you, but it's not required by the machinery directive. Okay, so if we take a look now towards the new machinery regulation, it's been a little bit streamlined. Here, first of all, we have different annexes, and then on the top again, you have any product that's not listed in Annex 1, you can do by yourself, what they call now an internal production control. And you can put the CE mark on your product by yourself. However, if you have a product which is listed in Annex 1 Part A, then you need to go and do some other kinds of examinations, what's known as the Module B, so an EU type examination where you have a notified body who's checking it, or some other kinds of quality assurance mechanisms. So if we take a look then and dig deeper into this Annex 1 Part A, what we see is there are certain things that are really associated, really closely tied with robotics and with AI. So for example, if I have safety components with fully or partially self-evolving behavior that use machine learning approaches, this is something that I am not allowed to test myself. So yeah, that's a lot of this idea that I have some kind of an AI system that is evolving, that is getting new data, and that I'm using that to, for example, implement some kind of a safety function, like if you see somebody gets closer, stop. I can train this beforehand, and I can use AI methods and then say this is a model that's been trained and it's not becoming changed anymore, and there's no self-evolving behavior over time once it's being out on the market. Then it's not part of Annex 1 Part A. But if I do have that, then it's going to be something that I'm not going to be able to put the declaration of conformity on by myself as a manufacturer. Okay, so if we continue this, we also have machinery with embedded systems, with fully or partially self-evolving behavior. And then also if I have protective devices that are designed to detect the presence of persons, or I have logic units that are ensuring safety functions, those are also things that I'm not allowed, according to this, to test myself. And so again, an example is I have a camera system that is a designated safety camera system that uses AI to detect people. These kinds of protective devices are something that I'm going to have to get outside expertise and help with to validate them before I can put the CE mark on this product. So from, again, looking at the issue of product safety, what's often interesting and important is the idea of safeguarding measures. And we have what's known as a hierarchy of safeguarding measures that we take, both from the manufacturing perspective and then later on down the stream as an end user. So the idea is with the hierarchy of measures, as a manufacturer and as an end user, I want to start at the top, and only if I'm not able to ensure safety based upon the top level, do I then go down one step lower. So of course, it's better to have an inherently safe construction. As an example, I have a robot that is limited by its motors, by its gearing, by its inertia, that even if it were to go at maximum speed and come in contact with me, those contacts would be below the biomechanical thresholds that are allowed for contact with that specific body part, right? So no matter what happens, no matter how I control it, it can't hurt you. And that's the idea of inherently safe construction. Now, the next step down is technical safeguards. Let's say I have a robot that's big and fast and strong with a high inertia, and I still want to slow it down, so I'm going to use a control system, and I'm going to use different types of sensors that in combination will detect when somebody is nearby, and then will trigger the robot to move slower to a so-called safer speed. Then I'm using technical safeguards. As a next step, I'm going to have user information, and as you can imagine, the level of safety that I'm getting out of putting a warning in a user handbook or on the machine is going to be much less than if I have a control system that won't allow a specific situation in the first place. And then looking at it from the end user perspective, we also have these technical safeguards. We have organizational safeguards where I make sure that, for example, nobody can get into the space where robots are working. And as a final step, I'm going to have personal protective equipment. So that kind of sounds like an American football player who gets a helmet and shoulder pads. But I think in our case, when we're talking about robotics applications, a helmet is typically used and maybe some protective shoes. So to wrap this up, again, as we've said, we have the Machinery Directive, and this is binding law for every manufacturer, everybody who's bringing a product onto the market in Europe. And the health and safety requirements you have to consider are in Annex 1. We have different procedures for evaluating the conformity, and it's important to understand that if I have AI in certain features of my system, like in the safety functionality or in the control system, then I'm not going to be able to do this conformity declaration by myself. If I'm looking at partly completed machinery, there are also some things that I need to consider. What's really important there is that I also have assembly instructions. For example, how to integrate my robot with other systems. And that's going to be a little bit different than if I have a complete system, of course. Yeah, it's of course separated kind of an idea from other directives that are available, such as the low voltage directive, which is also very important for robotics. Okay, so moving along, what we'd like to talk about now is the risk assessment process as part of the product safety approach. And what does this look like, and what do I have to do? And to give you some tips and some tricks and some ideas about how this process looks. So as we've already said, the main legislation regarding product safety in Europe is the Machinery Directive, soon to be the Machinery Regulation. We also have the Product Safety Directive. So the question is, how do I really define and how do I know when a product can be considered safe? And this is a really tough question because how do I know the different things that can happen and how do I plan for that? And the answer is, it's considered safe when the risk assessment and the risk analysis shows that the residual risks that arise from using a specific product in the different ways that the manufacturer or the end user thinks they will be used are as low as possible. So there are different systems for doing this. On the right side of this slide, you can see one of the ways of looking at it where you start and talk about the different levels of body harm, you talk about the frequencies, look at the probability of things occurring, and then you have a sort of a rough rating between green, yellow, and red. We also have what's known as the RAPEX Risk Assembly Guidelines. These are online from the European Commission, and these are something that you can use to guide you through the risk assessment process. We'll jump to the idea of standards. What is a standard? Are they mandatory? What are the different types of standards that are available that I can use? And what's the difference between a law and a standard? So here we have a standard, and a standard is all of these things. And it's typically an industrial standard. It's typically made, written by a group of people from the same industry who are focused on a certain application or a certain object, a certain tool. These standards are, of course, up to date, so they have to be updated in a regular interval, at least, I think, 10 years, and sometimes even more, often within like 5 years. Standards are very specific to an area of use. As an example, for robotics, there are different standards for robotics being used in healthcare than robotics being used in industrial applications, and also different from robotics being used in consumer applications. And so because of this area of use, it becomes very tricky, especially for something like a robotic system where the same hardware can be used for a different application. And all of a sudden you have to use different standards even though it's the same machine that you're using. The robotics community is aware of this. They are trying to address this in their standardization activities, but it's a challenge. And I think it also shows how robotics is different than other machines and products that have typically been used and created today. What's interesting about a standard is the idea that it's non-binding. So you don't have to use a standard. But since it's up to date and a state of the art and made by industry, there's the assumption that, that this is going to be a good way to, for example, ensure safety of my product. But you don't have to do it, and if your product is so new or so different, then you're basically going to have to find your own way to do this. Okay. The last topic here is the idea of a harmonized standard. And this is very specific within the context of the European Union. So standards are available, they're written, they're international, they are sort of best practice, they are consensual based. So typically you need something like 60 or 70% of people who can vote for a standard to be in favor of a standard in order for it to be used and to be published. The harmonized standard is an added layer on top of after a standard has been published, and it's basically reviewed within the European Commission by a specific arm, by CEN, and here this has then been reviewed so that if you use the so-called harmonized standard, then there is the assumption that you're also in conformity with European law. So it's the idea there is that it'll simplify all the things that you have to consider because if you're looking at a European law, the European law then references certain harmonized standards. If you use these harmonized standards and document that in your CE marking process, then there's the idea that the assumption that if something goes wrong, that you have done everything correctly because you've used these harmonized standards. And then it's upon somebody else the burden of proof in terms of showing that what you did was incorrect. And maybe going back a step, the idea of them being non-binding. If you don't use a standard in the context of the CE marking in European law, then the burden of proof is on you, and you have to show that your testing procedure or whatever procedures you had in place to show that you were conforming to the essential health and safety requirements, you have to show that. So it's basically where's the burden of proof in this situation. We have three different types of standards. They're called A, B, and C. They go from high level, mid-level, and very specific. And when we're talking about standards for a specific application, you're going to want to use the most specific one. So if there's any kind of discrepancies between, for example, a type A and a type C, what's in the type C is the one that is the most relevant for you for your application and has priority. So I've already talked about this, but I'll just say it again. If I use a standard, does it put me on equal footing with the law? No. But if you use a harmonized standard, the burden of proof is on the authorities in case something happens. So it's a pretty good idea to want to use those. Are standards mandatory? No. Again, burden of proof. And the final one is what types of standards are there? A, B, and C, where they are very high level and become more specific. If in doubt, use type C standards. If we look at the risk assessment process on the left side in the middle of this slide, it looks kind of complicated, but if you look on the right side, we see the hierarchy of measures that we're already familiar with. And here the idea is with the risk assessment process, we're going to move down these hierarchy of measures and we're going to use these, always asking ourselves, what can happen? What are the hazards that are imminently there, that are available with this machine and in this application? We ask ourselves, how can we reduce the risk by applying this hierarchy of measures? We document that, and then we ask again, after I've done that, are there still any more residual risks? And you keep going through this iterative process, documenting all the things that you've changed in your design, in your documentation, in your user manual, until you come to a point where you say, okay, risk reduction has been achieved, and the system is safe, and the negligible amount of risk that's still available is okay for me. So here, what we're looking at is the elements of risk according to the ISO 12100. And this is a standard, the ISO 12100, which talks about the risk assessment process and tells you how to go through it. So risk is defined as the severity of the harm that could occur and the probability that this harm could occur. And what you want to do is you want to remove all of these risks. And what's important is that you're considering this across the entire life cycle of your robot system or your application. So that means we're talking about doing tests first, commissioning it, setting it up, transporting it, decommissioning it, and disposing of it. And I think here it's also one of the things that we look at a lot these days, that's becoming more and more important, is the idea of recycling and reusing these machines. And it's also important that we consider the disposal, and for example, are there hazardous materials inside, and how can these be disposed of properly? And that's something that's maybe not always on the minds of manufacturers, is that they need to consider this entire life cycle. Okay, moving on. When we talk about the risk assessment for AI, this will be covered in detail by some of the other colleagues, but here I think it's important just to touch upon it, because the risk assessment for a product is a little bit different than the risk assessment that's being done if you're talking about AI in particular and you want to consider the risks of this AI. So when you talk about AI risk assessment, you're looking at high-level issues like bias, lack of transparency, discrimination, and erosion or damage of trust. And it's important here, these systems are typically classified depending upon the application, depending upon what can be affected and how people can be affected by this AI system working incorrectly. And here we talk about high-risk systems and low-risk systems. And there's a large range of different artificial intelligence risk assessment methodologies available right now. One of them is the FIRMA, and as I said, we'll see some other examples in some of the other modules here within the Regulate project. Okay, and just to send you on your way, what are some of the relevant standards that are related and going to help you out as you're doing these different processes? So I've mentioned the ISO 12100. This is the safety of machinery, and this guides you through the risk assessment process and risk reduction measures. We have some other ones like the ISO 26262, which looks at functional safety of road vehicles. We have the ISO 13849, which talks about safety-related parts of control systems. We have the ISO IEC 22989, which is talking about artificial intelligence concepts and terminology. And it sounds kind of crazy, but right now there's still lots of discussion about what is artificial intelligence, how do we describe it, and what's the language that we use to describe it. So moving on, we also have the ISO IEC 23053, which is the framework for artificial intelligence systems using machine learning. And then we have some other ones that are being developed right now, looking, for example, at guidance on the risk management for AI and looking at functional safety in AI systems. Okay, so moving on. When we talk about safety and certification from a manufacturer perspective, it's also important to know that it's part of the CE process, and what's also defined in some of the relevant robotic standards is that I need to do some own testing of my robotic system before I put it on the market if it has, for example, if it's used for collaborative applications. And so right now in robotics, there are some standards that are supporting me to guide me through this validation testing. Is what we're seeing in the video. It's how I can measure the forces and the pressures. The future focus of these standards will be towards simulation, so being able to do this through some kind of formal verification, being able to do this without having to conduct a physical measurement, which of course from a manufacturer perspective is very time consuming. And it's also not really in line with the idea of a flexible robotic system. Because right now the way it is, if I have a robot that is force and power and force limited, and it could come in contact with a person, I'll need to do these force measurements like you saw in the video. And if I change the program in a significant way, I will need to also redo these measurements. And that's far away from the idea of flexible robotics that are changing and deciding how they work in changing environments. If we have to stop everything that we're doing and do a new pressure and force measurement in between, that's not really how I think robotics of the future will look. So that again explains this idea within the standardization community, and which is also being sort of pushed by manufacturers and integrators and end users of robotics, is that this is simplified in a way so that it can happen online in a computer in a simulation. Okay, and what's also really important to realize, here we see in the video an example of how these kinds of safety assessments online could look. What we also see is basically, in terms of robotics with AI and in functional safety, there's also going to be some kind of testing involved. This will also be in the standards, but this is going to take a while. The standards communities are working on this right now. We have the joint committee, the SC42, between ISO and IEC, and they're looking at all kinds of different things regarding AI, and this is part of it. Of course, what we also have to consider are things like cybersecurity and these data implications, it's going to be a long path before we have these standards in place, unfortunately. Now we're going to look at post-sales duties. As a manufacturer, if you do the CE mark, you need to complete technical documentation, and you need to keep copies of this available, and you need to also keep copies of this for the different, let's say, versions of the product that you put out on the market from year to year. So as an end user, it's really important you have some kinds of brochures, and these are descriptions, these are data sheets. It's also important and required that you have maintenance plans if the product that you're putting out requires some kind of maintenance. We have product documentation, and this is really important. These are things like electrical plans, circuit drawings, layouts, and also things like any kind of static calculations that you're doing if you have forces and things like that that are involved where it could be critical. What's also important is you have the user manual. Has to be, of course, in the official language of the country it's being used. We're all familiar with the stack of the really thick user manual where it'll have 20 different languages or so. In the new version of the machinery regulation, it is okay that these are available online. So the idea is we'll reduce the amount of paper that we're sending around. And what's important is that you keep a copy of the conformity assessment, which is basically saying which standards you adhere to, what the name of the product is, when it was put on the market, the address of the manufacturer, and of course the signature of the person who is responsible. If you're the manufacturer and you also need to have some things internally in case something happens, and you also need to keep these. And the most important thing here is the risk assessment. So if something happens, if somebody gets hurt, for example, using a robotics application, an example of something that was in the press recently, there was a chess playing robot that moved the chess pieces while playing with a human. A kid was playing against the robot. They put their hand back on a part. They were done, let it go. They put their hand back on the piece, but the robot was already moving and didn't expect for the person to grab it, and basically crushed the kid's finger and broke it. And this was really bad. This shouldn't happen. And so, of course, then if that had happened in Europe, the authorities would have gone in and asked, where's the risk assessment? Did you consider this risk? And what mitigation systems were in place to make sure that something like that couldn't happen? Okay, so again, here what we see is that there's lots of documentation, and documentation is really important because that's the way of proving that you have considered all the different essential health and safety requirements when we're talking about robotics and we're talking about AI and robotics. Okay, so as a manufacturer, we talk about post-sales duties, we're talking about market surveillance, and this means that you have to put the CE mark on your machine. It means this technical documentation must be available, and if the authorities ask for it, these should be showed to them upon request. As we saw before, some of these things, like the risk assessment, are for the manufacturer only internally, and they do not need to share this with their customer. But if the authorities come, they do need to share it with them. And there, if they didn't do a diligent job, there will be lots of questions that get asked. Okay. And as a final step, it's important that as a manufacturer, you could be asked to take corrective actions and remedy any non-compliance that arises within a reasonable time frame. When we talk about post-sales duties from the user perspective, you need to make sure that the manufacturer provides you with instructions. And if they don't, it's up to you to tell them, hey, there's something wrong here. I'm supposed to get instructions with every document that I'm buying, or with every product that I'm buying, excuse me. And then it's also important for you as a user of these products to conduct your own internal risk assessment and to document that, and to also show that the people who are using your system, if you're the manager, that you've trained them and that you've documented that you've trained them and informed them about the different risks and about the risk mitigation measures and how they should act with this. So as an example, if there's a robot that I'm working with, and again, it's maybe this chess-playing robot, and if they see that the robot still moves even though the player hand is near the pieces, then there it's up to them to say something's wrong here and take the machine out of operation, right? Okay. Again, it's also important to know and to make sure that the machines that you're buying have the CE marking and the declaration of conformity is provided. And what you also have in terms of post-sales duties is that the EU member states themselves also have their own authorities that are conducting market surveillance. So they're monitoring conformity. If they're able to, they're of course not going to be able to check the documentation for every single product that's put onto the market. But if something happens, that's when they'll be there. What they can also do, which is a very powerful authority given to them, is they can withdraw products, they can call for a market recall across all of the member states. Okay, so we've talked a lot about product safety, we've talked about standardization, and we've talked about post-sales duties. And I think it's important to look at this in the context of a real application and to understand what this means for me. So here we have a case story. We have a fictive manufacturer who was tasked with installing a robotics application in a factory. So there's the factory owner, they contract the specialist system integration services, and they come in and they use an off-the-shelf cobot, and they integrate it with a gripper, with a camera system, and they do some kind of operation. And this is being used in the factory. So it's pretty clear who the manufacturer is. It's pretty clear who the end user is. After 6 months of use, something happens. Somebody was hurt, and it seems that the robot was dropping parts every once in a while, disrupting operation, and the person was reaching in when they shouldn't have, and they tried to help, let's say, the robot to solve their application without it going into a stop. In doing so, their hand was clamped, and they were injured. Here's an idea in the video of how some kind of a clamping could look. Yeah. Okay, so what happens next? The local health and worker authorities come in, and what they're going to want to know is if you report the accident, then the authorities know about it, and they're going to do some investigation. So they're going to want to see the CE certificate. They're going to want to see the risk assessment documents. And in this case, for example, they'll see in the risk assessment, this is again just an example, that the risk mitigation that was chosen was power and force limiting. So what they're going to do now is they're going to ask, where are the measurements? Where is the validation measurement that you should have done to prove that the forces when a collision occurs are below this certain threshold? So in this case, let's say they didn't know. So they had thought that relying on the robot's program was enough to say it was programmed to stop at a certain force, and that's enough. But that's not enough. And that's why the validation measurement is important, because these sort of applications are very complex, and it's not just the robot program itself that can limit the force. There are certain things like the pressure involved, and there it's also the geometry of the parts that are being moved around. that play a large role here. So in hindsight, they were taught about how this is done, and then they were trained about how to do these validation measurements. So they reviewed this then, and they had to also go back and do these measurements for any applications that they had that were similar, so any other products that they had out on the market. Okay, so moving forward then, let's look at another use case where we have a company that's using AI. We call them Miracle Robotics Limited, and they're using a proprietary AI technology to detect humans and to differentiate between different people. And they want to use this in robotics applications, but they're not quite sure what are the liabilities, what are their responsibilities when they're using this in a safety-related application. So let's take a look. What do we learn today? We see that if we're talking about safety-related applications, this is going to fall under Annex 1, Part A for CE marking, according to the new regulation. So that's one thing to consider, that we're going to need to go to a notified body, and they're going to have to do this process with us in terms of testing these systems. The next question that we're going to ask, of course, is the application self-evolving or not? Because that's, I think, also a big part of whether it falls under Annex 1 or not. And then it's important to consider the risk assessment. So what are the risks that have been considered? What's the hierarchy of mitigation measures that have been applied? And then also, again, what is the intended use for humans, and how can this foreseeably be misused? And that's also an important part of the risk assessment process. And as a final step, it's important to understand what happens if something malfunctions. And here it's important to go technically along the entire technological tool chain to say, okay, from my computer, from my camera system that I'm using, how many different cameras do I have? Are they redundant? Can I check, for example, and safeguard that if one camera isn't working but the other one still is, that they can check each other and things like that. So what are the layers of safety-related technologies that are involved? And those are some of the considerations you're going to have to do as a manufacturer. Okay, so tying it all together, as a general overview, product safety is important both from the manufacturer perspective and from the end user perspective. Within the EU, it's important to know that the member states have their own authority to check conformity of these products to ensure that the essential health and safety requirements have been fulfilled. As a manufacturer, you need to be aware of your obligations to maintain documentation. And as a user, you also need to be aware that you need to ask for these, make sure that you have them, and that you also do your own internal risk assessment. Here are a few links that you can use. Thanks for your attention. It's been a pleasure talking with you here today. If you have any further questions, I hope that you can either contact me later or that any of the other Regulate modules, which also focus on the risk assessment process, look at liability, look at issues around data privacy, will also help you further along with your products and with your questions regarding AI and regulation. Thank you very much. Bye-bye.